Hi guys, welcome to this brand new series of tutorials on microservices. So we'll be looking at in-depth concepts of microservices world. So in this course basically we'll be looking at below topics. So first we'll see the overview of microservices. Then I have created architecture diagram for you for the application which we are going to develop in this course. Then we'll set up our Maven project. So we'll be setting up parent project structure, and then inside that parent we'll be creating a child projects which are the microservices basically. Then we'll set up Postgres database in Docker Compose. Then we'll create our first microservice which will be in Spring Boot 3, which is our customer microservice, which will be responsible for handling customer registrations. And then we'll go for fraud detection microservice, which will actually check if that registered customer is a fraudulent or legitimate customer. Then we'll handle intercommunication between this customer and fraud detection microservices using a REST template. Then after that we'll create one more service called Eureka service, which will actually handle a service discovery part. So basically, if customer wants to talk to fraud detection service, then both of them will register against a Eureka service, and that way they will customer would be able to identify a fraud detection service through the service Eureka service registry. Then we'll look at the load balancer concept, what it is and how it works. Then we'll go for developing Fain clients. This is this is another way of intercommunication between microservices, which is actually a more efficient way than the REST template. Then we'll go for notification microservice. We'll develop it, and which will be basically handling the notifications coming from customer microservices. Then we'll implement distributed tracing and logging for our microservices based architecture. That will be handled through Micrometer in Spring Boot 3. Then we'll create a Zipkin dashboard. So Zipkin will be handling monitoring part of our application, which will be able to identify latency and performance issues in our microservices architecture. Then we'll develop API gateway service, which will be handling the external communication. So basically, all the external requests coming from the outside world into our microservices world will be happening through this API gateway. Then we'll see what asynchronous communication is in our microservices architecture. Then we'll implement this using a Kafka message broker. Then we'll look at Maven build. We'll try to build all our microservices. Then we'll use a Zip plugin for creating Docker images of our microservices application. We'll push those images in a Docker registry. Then we'll run all those images in a containers uh, in a Docker. Then we'll see how to deploy these images into a Kubernetes platform. We'll be using following frameworks while we develop this microservices along with this course. So we'll use Spring Boot version 3, we'll use Spring Cloud, we'll use Spring Data GPA to interact with the database. Then we'll be using these tools, IntelliJ editor for coding purpose. We'll use Postgres database, we'll use pgadmin as a database editor for firing the queries on database. We'll use Maven as a build tool. We'll be using Docker as a containerization tool for this project. Then we'll use Zipkin for application monitoring purpose, and Kafka for asynchronous communication, and Kubernetes as an orchestration platform. This course basically focuses on practical knowledge of all the microservices concepts. You'll be doing hands-on for developing all these microservices along with me, and I hope you'll be getting in-depth knowledge of all the microservices concepts, and you'll be able to create microservices on your own. Thank you.